So thank you all for joining us. My name's Kirk Blaine. I'm the Southern Oregon Regional Coordinator for the Native Fish Society, and it's very exciting to offer this opportunity. This is our first Lunch and Learn, and it's exciting because we had about 16 people, and it looks like we have 11 participants on the phone right now. So pretty awesome opportunity to have. I am going to, there's a couple folks that are still registering right now, or being brought into the room. So I'm kind of bringing them in at the same time. But today we're going to have Jodi Wilmoth, our Little Deschutes River Steward, do a presentation on bull trout eDNA testing. We'll kind of go over some of the things that that she does in regards of doing that bull trout eDNA testing. And then we'll have time for question and answers after the presentation. I do want to send a big thank you to Jodi for putting this together and being able to give this opportunity to us for our first Lunch and Learn. I also want to extend a huge thanks to our Women for Wild Fish program, Tracy and the other folks, because without them, we wouldn't have been able to make this happen. And then lastly, to our two volunteers that came out. Patricia is with us today. She's on the call, but they came out and helped us with a project that Jodi's going to explain here in a minute. But without them, this project wouldn't have been possible. So Patricia, thank you. And Amy, they came from the Redmond and Madras area. So with that, I'm going to cover a little stuff with Zoom for those of you that aren't familiar. If you could go ahead and mute yourself unless you're speaking. We'll have Jodi speak first and give her presentation. After that, we have a small enough group that I think we can unmute ourselves and ask our questions personally. If you prefer, feel free to type a question into the chat and I'll ask Jodi as well. But with that, we'll go ahead and turn it over to Jodi for our presentation.
Well, hi, everybody. You'll have to forgive, my video is not up. I had practiced this and for some reason right now, of course, when it really matters, it's not up there. So thanks, Kurt, for the introduction. And it's great to see you, Patricia. I can see you on there. So a little bit about me. I've been a Native Fish Society steward for about 3 years. I work in the Little Deschutes Basin, which is a tributary to the Big Deschutes, and I've got some maps available to see where it is that I work. I would say I'm a sort of a native species advocate, not just for fish. I also work with Oregon spotted frog conservation. A lot of that is through actually bullfrog control here in the Deschutes Basin, which makes for some fun nights and some interesting conversations. And then I'm also sort of a freelance environmental consultant. So that's my background a bit. So we're going to talk about this project, this bull trout environmental DNA project. Just to get into it, I've shared my screen. I think everybody can see that. For short, it's called eDNA, but it is environmental DNA. And some of my experiences along with our volunteers about going out and collecting samples, what it takes to be able to take on a project like this if you're interested in doing this in your watershed. Excuse me. So we're going to talk just a little bit about the background of bull trout, which I'm sure many of you know, an overview of what environmental DNA is, eDNA. The project that I got involved in, which is the range-wide bull trout eDNA project. Some of the challenges that I've run into trying to move through getting some of this sampling done, and then also some goals and some opportunities that I think are out there for this type of project. So as far as bull trout goes, as many of you know, it is a species of char. So it's related to the dolly barden and the brook trout. And it's my understanding that there are instances of the bull trout and the brook trout hybridizing. So it is my understanding that they can mate, which is a problem. But quite often the brook trout and the bull trout inhabit the same sort of headwaters habitat, so they see each other quite a bit. and brook trout will often outcompete the bull trout, and they're just overwhelming numbers. The bull trout have the most specific habitat requirements of all of the salmonids. They love very, very cold water, which is one of the reasons you find them in these headwaters. Some of the places that I've explored are spring-fed rivers, spring-fed creeks, and the water's coming out of the ground at 35, 37, 45 degrees, and these bull trout just love it. Just bring it on. They love really, really cold water. Obviously clean water, and then complex and connected habitats. That's the case for all of our salmonids, but these bull trout are quite migratory, not necessarily from the ocean into rivers like our salmon, but they'll move from one river into a lake and then into another river. They'll go down the river and go into the Columbia and then back up a different one. So they are quite migratory, even though that doesn't involve necessarily a saltwater aspect. So that connected habitat is really important for them. And with the fish barriers and the dams, it's definitely one of the threats that they're running into. How spectacular is that bull trout in that picture? It looks like a king salmon. It's so big. And yeah, that's from 1949. It's a massive fish. So real quick, the bull trout were listed as threatened in 1999. So they've been on the endangered species list for quite a while. You can see on this map the places that they used to inhabit. They're no longer found anywhere in California. I believe there's a few left in Nevada, and most of them, as far as in the United States, Washington, Oregon, Idaho, and Montana. I do feel like this map needs a little bit of explanation, because if you just look at it, it looks like the bull trout are still in 90% of the places that they have been. But keeping in mind that connected habitat, they've been disconnected from a lot of the places that they used to migrate in and out of. So there's more like pockets in these areas than there is, continuous habitat like it used to be 100, 150 years ago. So they currently occupy less than half of their historical range, hence the threatened designation. I did want to mention that the bull trout is under the U.S. Fish and Wildlife Service. Most of our fish species are under the National Marine Fisheries. Because this is an inland species, it is overseen by the U.S. Fish and Wildlife Service, which can make some differences as far as regulatory and dealing with that particular agency. Some threats for the bull trout, which is the case for a lot of our salmonids. Climate change, especially for a species that is so cold water loving, is a huge challenge for them. And finding that cold water refugia is even more important for this particular species than a lot of other of our salmonids. Non-native fish introduction, particularly the brook trout, is very challenging for the bull trout's continuing existence. Habitat degradation, and then those fish barriers and habitat fragmentation, just like I had mentioned before, the migratory nature of these fish, even though they're not going back and forth from the ocean, they still roam a long, long ways. So the project that I got interested in is actually sponsored and is run by the U.S. Forest Service over in Montana, the Rocky Mountain Research Station. What you're looking at as far as this map goes are places that their climate shield model has identified as places of cold water refugia for native cutthroat trout as well as bull trout. So these sites are not all over Washington and Oregon. They have identified specific drainages where there's cold water, where they think that there's a decent chance of finding bull trout. So that's what you're looking at there. And the idea is kind of that the eDNA collection is crowdsourced. So the Forest Service is not necessarily the one that's going out there and collecting all these samples, that there are other agencies, state fish and wildlife agencies, USGS, NGOs that are getting involved in the project and will go out and collect samples and send it back to them for their analysis. because it's a very wide-ranging map, obviously over state lines. It's a great idea. And then the project was initiated in 2016. It went on for 3 years. They only had funding for those 3 years, but they continue to accept samples and analyze samples, but you have to find funding to get those samples analyzed, which is one of the biggest challenges. And each one of these samples is $85 a piece to analyze for bull trout. You can tag on other species, and we'll talk about that for an additional cost, which is kind of cool. But I put up the website. You can just look up the range-wide bull trout eDNA project if you're interested in finding your drainage, your area, to see the collection there, and also what the results of that collection was, what the results of that analysis was. So they've got some really good information on that website. Excuse me. A little bit about eDNA. It's a pretty cutting edge technology. It's very recently started being used in the conservation arena. My background is in molecular biology, so I've studied DNA and RNA for a long time. So this is really an exciting project for me to be able to wrap it up into conservation biology. And environmental DNA just means that the sample isn't taken from the organism itself. It's taken from feces, it's taken from the water, it's taken from soil, but there's no interaction with the actual animal, which has a lot of benefits, especially for an endangered species. And it can be taken for mammals, fish, amphibians. It's being used both terrestrially and in water sampling. And mostly it's used for rare species and shy species, low numbers of species, for various reasons. Traditional sampling for species that, like a rainbow trout would be more cost effective. But if you're looking for a rare creature, then this is the way to go, and hopefully the future. So some of the benefits of this eDNA: you can collect one sample and have it analyzed for multiple species. So even though I'm having them analyze this for bull trout, I could have them analyze it for rainbow trout, for say Oregon spotted frogs. So they can go back, and even 5 years from now, because they're going to be cataloging all this DNA, if there's an agency or someone that wants to know about these samples for a completely different species, they can go and probe for it. So that's exciting that that's going to get cataloged, and that information will be there. Easier, cheaper, less harmful than traditional techniques like electrofishing, especially for again, a threatened or endangered species. The least amount of handling for these creatures, the better. The other benefit of that is when you are handling, if there's a take, which means handling of, or many things, but one of the things it means is handling a threatened or endangered species, you need a state and federal permit to do that. And that can be a long process and a difficult process. So that's another one of the benefits. You don't need a state or federal permit to go out and collect these water samples. Great for the fish as well, that they don't get handled. It's a lot less stressful. The other benefit is it's pretty limited training involved before you can walk out into the woods and start collecting samples. And that means that, maybe you could get kids involved. Maybe you could get, field trips involved to collect samples, teach these kids. It's a great STEM, education. So lots of opportunity for the general public to get involved in the project. And then just a couple of the negatives: it doesn't provide any information on the life stage that's inhabiting that drainage, the health, or even the abundance. They are working on technology to be able to extrapolate that, to be able to figure out how many fish might be in that particular area, but that's not out quite yet. There's also a possibility of contamination. And if any of you have watched True Crime or any of those shows, they talk about contaminating the site for DNA, and that can also happen with this. So you have to be careful about keeping your technique clean. Then there's also something called zombie DNA, which means there's DNA that's still there, even though the individual or the group of fish has either died or moved away. And then DNA can degrade quickly, especially in warm water, in lots of sunlight. So the typical amount that I've seen that I've looked at on the internet as far as how long it can stick around is about a month, but there's a lot of variables involved in that. Like I said, water temperature, how much the sun is shining down, sun degrades DNA. So there are some drawbacks to this technology. So this slide is showing some of the equipment that is used to go out and collect eDNA, and all of this is sent from the U.S. Forest Service in Montana. You can contact them and they will ship it to you. So what you see in the top left-hand side is all of the equipment. You can see that there's a pump at number 2, some tubing. This is about 30 pounds worth of equipment, which is great to have a second person hauling this, helping you haul this up and over logs, because it can be quite heavy, and the ground is pretty uneven. There's not always trails everywhere. So this is a picture of me getting an eDNA sample here. You can see the pump. This is where the DNA gets collected, is in this on a filter on this little cup. And then the water gets pumped through this peristaltic pump and into this bucket. And the reason the water gets pumped into the bucket is because you're supposed to pump 5 liters worth of water. And that's just one of the controls that U.S. Forest Service has put in there to make sure that everybody's pumping the same amount of water, not 10 liters, not 1 liter. It's just a control that they've put in. And so you measure how much water you pump through that particular filter. There's a battery that you have to haul, and various electrical cords. It looks a little daunting, but once you get out there, it's pretty self-explanatory. And then right here, this picture in the middle, this is the cup, and then there's a paper filter that the water gets sucked into, and then the DNA, in theory, gets captured on this filter. And then you have a pair of clean forceps. You put the filter into this Ziploc bag, and you label it with all of the things that they need. And this is desiccant. So the filter gets put in this desiccant, and then it gets shipped back to the Forest Service they'll extract that DNA off that filter and then analyze it. Any questions so far? I take a drink of water. So you'll have to forgive the sort of elementary nature of this particular slide. I just put this together because I couldn't find anything really great that explained what it was that this project was doing. So this is just me sort of all but drawing on the on PowerPoint. But this is how it goes. You've got your bull trout, and hopefully there's DNA in the water. You collect your water sample, and you send that sample off to Montana, to the Rocky Mountain Research Station. And down here, the idea is you've got your bull trout DNA, and DNA is double-stranded in general. So what they'll do is they'll make that double-stranded DNA single-stranded, usually by warming it up, and that separates the DNA strands. And what they've done is they've designed what's called a primer, and what it is DNA that is very specific to bull trout only. And that's what's represented in this little green square here. So this is bull trout DNA that's specific to bull trout. And then they've designed something that is the complementary to that right here that they know is bull trout specific. And then this little star represents the way that they'll be able to see that it has hybridized, to see that there's a positive is what this blue star is. So they put these primers in here with the single-stranded DNA. Hopefully what's called hybridizes. If there's bull trout DNA in there, it'll come together with that complementary DNA. And then what they do is something called PCR, which is just an exponential growth of this double-stranded DNA. So even if you start with a very, very small amount of DNA, because of this PCR process, they can make many copies of it, and then they can see if it's a yes or no, even if it's a very, very small amount of DNA. And so that's pretty exciting. And they'll be able to detect it through fluorescence or some computer blip. At this time, I'm sure the technology has advanced quite a bit since I've gone to college. And then they'll know if that's a yes or no on that sample. So that's a very basic explanation of environmental DNA and PCR. As far as where I work in Central Oregon in the Deschutes Basin, down here way far south in the Little Deschutes Basin. So this is the Big Deschutes right here, which I'm sure many of you or all of you are aware of. The Little Deschutes is a tributary to the Big Deschutes. And then Crescent Creek is a tributary to the Little Deschutes. So this is a basic drawing of where I have been working. And most of the samples that I've collected have been right here around Crescent Lake. So if you are interested in seeing if there's any potential sites in your area or are just curious, this is what you're going to see when you log on to their website. You're going to find the drainage of interest. And then this is also represented in a spreadsheet, but then they have this PDF as well. And what this does is, this is the Little Deschutes that you see. And then I've taken this part and expanded it so you can see just a little bit clearer. So Crescent Lake is here, and then these different color codes correspond with the probability of occupation of bull trout. So Whitefish Creek right here has a 90 to 100% probability. Now that's based on what's called their climate shield model. So it is just a model. And that climate shield model is something that identifies very cold water where these bull trout and then the native cutthroat trout might be living. Not in this one, but so it's all based on a model. Just keep that in mind. So the blue has got 90 to 100, and the green up here, which is another place where we sampled, has 75 to 90% probability of finding bull trout. Just a note on this particular area, Crescent Lake. It's a big lake. It's about 275 feet deep, so it's a pretty significant lake. But there's an earthen dam at the bottom of it that Crescent Creek then comes out of. It does not have a fish ladder, so it is a complete fish barrier, right? And we talked about how those bull trout like to migrate. So even if we found bull trout over here, they can't come into Crescent Lake or into Whitefish Creek because of this dam, which is a bad thing. But on the other hand, it also, if we were to find bull trout in Whitefish Creek, it would keep any more brook trout from migrating into that habitat. So there are pluses and minuses of this complete fish barrier if we were to find bull trout in Whitefish Creek. So that's what it would look like. They have one of those for every drainage that they've identified to tell you what the probability of different finding bull trout in different drainages. So this is Amy. She was one of the volunteers that came out with Kirk and Patricia. She was a trooper because about 2 miles, there was no trail. We had to haul all of this equipment over logs, and it was quite challenging. And that's one of the biggest challenges of this collection, is that there's not always trails right next to these creeks. You are finding your own trail, and you got to be a pretty good navigator to do it. So that's one of the biggest challenges, is just access to the sites. The equipment, again, you get all of it, but it is a little bit heavy. The other challenge is you only get one set of equipment per team. So if you wanted to go out and collect if you want to send multiple teams out, you would need multiple sets of this equipment that the U.S. Forest Service would have to send to you. The other challenge I have run into is, when is the best time to sample? These bull trout can be very migratory. Like I mentioned, are they going to be in this creek at this time or this time? Should I sample in July? Would that be the best time that they would be in the area? So that's been a challenge. And then the cost of analysis at $85 a sample. If I want to do 100 samples, you know, that's basically $10,000. And then you have to ship all the equipment back to Montana. But this bottom map right here is the map that I came up with, where I took the US Forest Service GPS coordinates and transferred them onto my Google Earth so that I could know when I was out in the field exactly where to go to get these samples. Excuse me. And last slide here. As far as the goals that I have, you know, why am I doing this project to begin with? Obviously is to establish whether or not there actually is bull trout in any of these drainages. Both US Fish and Wildlife and ODF&W has determined that there are not bull trout here. And according to some of the people that I've talked to, their research in their occupation was not very extensive. And the reason that it's important is, you know, we have some issues going on with the upper Deschutes right now with irrigation districts, and there's just lots of things going on. And if we can prove that there's bull trout here, that means that US Fish and Wildlife has to establish critical habitat for these bull trout, which comes with special management and protection for those watersheds to have a threatened species found there. But they say they're not anywhere basically above places on the middle Deschutes. And who knows, they might be right. If we do find bull trout, there's a lot of, I'm hoping that there would be additional grant opportunities and partnerships with both state and federal agencies to continue to go out and establish where these bull trout still remain and the steps that are needed to be taken to make sure that they do remain there and that they're protected. There's lots more samples to be taken along the little Deschutes, just in the little Deschutes and throughout the West. So there's lots more to be done. I had already mentioned the citizen science part of it, that there's very little training that is required, and that's really exciting, especially to think about engaging kids in something like this. We're always looking for, you know, there's a lot of people in Central Oregon that are looking for volunteer opportunities, and this is a great one that's using cutting edge technology for conservation biology. It's the best of both worlds. And then again, I mentioned the agency partnership. I've spoken with lots of people from the US Forest Service as well as Crater Lake National Park, and there's a lot of interest in this eDNA, and it doesn't sound like something that the agencies have really stepped into quite yet. And they're very interested in learning about this information and what the results of this testing is. And to wrap up, I just wanted to thank Kurt and Tracy from the Native Fish Society for all their support. Kurt came out and took some samples with us and got boots on the ground to see what the process is actually like. Patricia, who is on the call, this is a picture of her over here on the right, and then Amy as well. We're both great in enthusiasm and just getting dirty and wet and whatever it takes to get these samples. So that was great. And then also to thank the US Forest Service and at the Rocky Mountain Research Station for answering a ton of questions that I have and sending me all this equipment. So that's it.
Awesome job, Jodi. Thank you so much.
Yeah.
So we did have a couple of questions pop into the chat while you were presenting.
Okay.
I don't know, Stephen had a question. Did you want to ask that question, or you want me to go ahead and relay that out, Stephen? Okay. So does the salinity further degrade sample viability time?
I don't know the answer to that question because I haven't really looked at eDNA in relation to saltwater environments. I know that there's still some questions about eDNA in in lakes and large bodies of water. At least the group that I've been talking to, they've been really focused on small streams. So I haven't really looked into how this would go in, you know, in a saltwater environment. So therefore, I don't know anything about how a salinity changes, how long the DNA lasts, if that is the question.
I think so.
But there's actually lots of information on the internet about eDNA. It's great that the information is out there, but sorry, yeah, I don't know.
Nice. Well, Jay Michelle, our very own Jay Michelle, was wondering if there are, let's see, is there a difference between Dolly Varden and Bull Trout, or are they the same?
They are different species.
Okay.
Like
they look very similar, but it's my understanding that they are different species, and that Dolly Varden inhabit more of the coastal areas,
Yeah.
and that Bull Trout inhabit more of the inland areas. But if you have different information, I would love to hear it.
No, Jodi, this is Jay Michelle. I don't, but I keep getting conflicting data on that. So that's why I like to ask everyone. So
I did, and I read it actually just this morning that they are considered separate species, but
perfect.
I feel like I'm in your same camp, that I've heard multiple things. At this point, you know, they can tell genetically whether or not they're one species or two.
Yeah.
From everything I've seen, they are two species.
Yeah. Thank you.
So our next question, Jodi, was from Gabe, and he was wondering if there is, when were you expecting to get the samples back, or the results back from the samples?
Good question. I don't have any funding. So what I've done is I've collected these samples, and the Forest Service is keeping these samples for me in their, you know, -40 freezer or whatever, until I can get the funding for analysis.
So
I don't have any answers yet.
We're working really hard in raising the funding to make these first couple samples happen. But yeah, still working for all 100 samples, hopefully.
Yeah, getting 100 samples. When I first started this project, I thought that I could go out in a weekend with a couple of people and collect 100 samples. And now that Patricia and Kurt and Amy and I went out multiple times, it's going to take a lot more than that. It's going to take some time to get a lot of samples. Right now, I only have about 17, and that's from the highest probability sites in the drainage.
Hi, Jodi. This is Mark.
Hi, Mark.
I just want to say awesome presentation. Thank you so much.
Yeah.
And we're pretty excited on the fundraising side. We are kicking off a raffle for a drift boat that's been donated by Ray's River Dories. And they threw in a trailer, a Baker trailer, and Sawyer paddles and oars, threw in a set of oars. So we're pretty excited about that. So yeah, we want to use the proceeds will go toward those eDNA, processing those eDNA samples. So stay tuned for emails and social media and so on. But yeah, we're really excited. We want to definitely link to this video so folks can learn more about the project. But thanks again. Awesome presentation. And great work.
Yeah, it's a really exciting project. It's risky. You know, we don't know if we're going to find Bull Trout eDNA up there, but like I said, the cutting edge genetic technology partnered with conservation biology just is the best of both worlds, in my view.
It looks like Gabe has a follow-up, but I'm going to transition over to, it looks like Marshall has a question. Marshall, you want to go ahead and unmute yourself and ask?
Okay, it looks like I'm unmuted now. Can you hear me?
We can hear you, Marshall.
Okay, well, I got several questions, but one of the things I noticed is the worry down here in the Klamath Basin. There's 100 sites, only a few of them have been sampled. The brook trout hybrid with the bull is sterile, and that's why it's particularly harmful to the native bull trout. And maybe that can be confirmed, but that's the story I'm getting.
I've heard that as well.
Okay. What's the cost to the other fish? Did you go ahead and mention that, if you want to add other fish in the sample than just the bull trout?
Sure. I don't think I mentioned it. So the initial sampling is $85. So just the one species is 85, and then you could tag on other species for an additional 35. And when I spoke with the Forest Service, both down in Crescent and over in Sisters, they were very interested in probing this DNA for rainbow trout, because they've been looking for rainbow trout in some of these drainages where they expect to find them and they haven't found them. But if they want me to do that, then they're going to have to help pay for it. But yeah, it's an additional 35 for each species to be probed above and beyond the initial species.
Okay, we have some rainbow red band isolated populations here. One of them may be extinct, but we'd like to sample the springs there. It's not in the bull trout sites. Will the Forest Service still accept those?
I don't know what their goals are for the rainbow trout. So the Forest Service will, that's a good question. I see what you're saying. Will the Forest Service analyze those samples specifically? Even though they're focused on bull trout? Is that what you're asking?
Yeah, they're not their points. We have 100 data points here, and they're outside of those data points that they want sampled.
Yeah, that would have to be, and the Forest Service over there in Montana has been very good about getting back to me both by email and by phone. They are really good about answering some of these questions. So I don't have an answer to that if they're willing to analyze samples that are outside of their data points that they've established with this bull trout model. That's a good question. I don't know if they would or not. I would think that they would, but they would be great to, I'd be happy to send you contact information.
Yes, and I hope we can send in additional questions later.
I can help arrange that, Marshall. We can make that happen.
Yeah, that holds me for now.
Cool. Gabe had another question real quick. Could you ask what the expected margin of error for the samples might be? And if they found evidence of bull trout in one sampling site, but the next site up, the creek didn't, what would they assume if there wasn't any barrier passages? So it looks like two questions. The first one being, what's the expected margin of error for the sampling?
I can't answer that question. Okay. I'm sorry.
No worries. But the second one, I know we talked about a little bit when we were out there sampling, but if they found evidence of bull trout in one sampling site, but further up the stream or creek, they didn't, what would you assume from that analysis, and if there wasn't any barriers?
Sure. So the way that you sample these drainages is that and I don't remember if I mentioned it or not, you always start at the bottommost part of the river, of the drainage, of the creek. So you wouldn't start at the top and work your way down, because you've increased your chances of contamination. So you start at the very bottom and then you work your way up to the uppermost sites that they put up there. So that decreases your chances of contamination. As far as I feel like my focus has been so much on whether or not that if there was any yes or no's, because any sort of even hint of yes in these drainages would be a win for us. I haven't really thought about any more of the specifics. If there's one yes, it's a win. I mean, we would obviously confirm that. And some of the sites that I've sampled are attached to lakes. So it would just mean if you got a yes from down below and a no from up further, you would end up sampling all those sites all over again to confirm. It would just mean that the bull trout are down lower and not up higher. One thing that I have run into, and Patricia and Kirk and Amy can talk about this, we ran into a lot of dry drainages. drainages that they said there was 90 to 100% possibility of finding bull trout, and there's no water there. It's sad, but it was the truth. So these even juvenile bull trout maybe have been pushed down to the very bottom of these drainages because the uppermost ones don't have any water in them. So I don't know if I've answered your question or not. It would mean that the bull trout aren't up further, but they're hanging out down lower. But if you got a yes in one of these drainages, at least in the little Deschutes, you would go back and confirm the whole could, and then move from there.
Awesome. Well, if there's any other burning questions or anything, please answer. Stephen has one more question real quick here. Maybe you can answer that real quick, Jodi, but if the money was there, what would the typical turnaround time for the results be?
They can get them done in a couple of weeks.
Okay, awesome.
And especially now, because I think that most people sampled during the summer, and the sampling is pretty much complete now. There's no competition for any of this equipment, but it's my understanding when I read through the website and then also talking to some of my correspondents there that they could turn it around pretty quick. The process is very quick. You can analyze this DNA in a day.
Wow.
You can analyze it in 2 hours. I know because I've worked in this field before. It's a question of, you know, what their bandwidth is, but the turnaround can be very quick.
Nice. Anyone else have any questions for Jodi from today's presentation? Awesome. Well, I do want to just leave everyone with a big thank you for coming out today. I know hopefully this was convenient during the lunch hour and easy to pop in. Awesome information from Jodi. So I want to thank her again. Also Patricia for joining us today and that Saturday. Native Fish Society does have a couple of things going on right now. For instance, we have an action alert that went out this morning for the Chehalis Dam. Check that out. Opposition to that dam and helping with your groundswell of public support for opposition to that would be great. We also have opportunities to volunteer completing red counts on the White Salmon River in the month of November. If you're interested in this, feel free to respond to my email for this presentation, or you can feel free to reach out to Jay Michelle, our Washington coordinator. You can see her on film on the screen, thumbs up. Feel free to reach out to her to participate in that, and that's going to be ongoing, not just in November. Lastly, continue to advocate for the Klamath River dams to be removed down in California. We need all the support with that we can get. And then lastly, we look forward to hosting more Lunch and Learns in the future. So if you enjoyed this, please, we'd love to hear your feedback. Write us an email, share. We'll be posting this online and sharing it with folks. So if people couldn't join, feel free to let them know. And other than that, thank you, everyone. Jennifer's on the call with us, and so is Jay Michelle. If you have any questions for them, we'll be on for a second longer or whatnot. But thanks.
Thanks, everybody.
Thank you, Jodi. That was great.
That was fantastic, Jodi. Thank you.
You're welcome. It's so good to see you guys.
You too.